All right, hello. Here we go. How's it going out there? I am Matt Andrzejewski, and I'll be your instructor for Psychology 215 Basic Statistical Methods this semester. This lecture is meant to be an introduction to the class. Um, if you want to find out a little bit more about me, I've posted some instructor videos and then a really long-winded one where I go into all sorts of nonsense. And you can watch those at your leisure and go from there. But this lecture is meant to be just an introduction to the course, what I expect, sort of go through the syllabus a little bit and so on. But I think the first thing we need to start off with is why we study statistics in the first place. And it turns out that statistics become really, really important because we as psychologists, really what we're trying to do, I think, mainly is make the world a better place for people and animals and conscious creatures. And in order to do that, we need to learn about our world. We need to figure things out. We need to determine what's best and what's worst and what's good and what's bad and those sorts of things. And we can do that in a number of ways. We can sit down and we can think critically about them. And that'll get us maybe an answer. We can ask some authority. We can go to a figure who claims, or maybe even falsely claims, that they know a lot about something. We can ask them their opinion, or we can maybe have a religious experience, and maybe that gives us an idea of the world and how it is and what we can do about it. But really, the surest way to learn about our world, the best way, I would argue, to figure out what's going on is to collect data, is to do an experiment, really, is to do some research on something, to figure out the reasons, because critical thinking, authority, and religious experience, these all are fraught with problems. It's not that science is perfect. It's not that collecting data is perfect. But it's better than just critical thinking. It's better than asking an authority. It's better than a religious experience. We don't care in science, how you feel about something, or we don't care that you're an authority figure in something. We want to know your reasons. We want to know your evidence. We want to see how it is that you've come to this conclusion. So collecting data is the surest way to learn about the world. Now the problem with that is that data in the behavioral sciences are really messy. In the physical sciences, for example, they're not so messy. So if you want to determine the boiling point of water at sea level, all you got to do is really one careful observation, and you'll get that value, 100 degrees centigrade. But data in the behavioral sciences are really messy. Observations or measurements of some property of people from person to person are different. It's just a jumble of numbers. So to make sense out of this data, we're going to use statistical procedures. That's what statistical procedures do, is they help us make sense with these jumbles of numbers and these data. So statistical procedures are tools for learning about the world by learning from data. Okay, to illustrate these principles, these practices, to explore our world, we're going to be actually using real data. We're going to be working through an experiment called the smoking study. We refer to it as the smoking study, and the second one we refer to as the maternity study. The smoking study was conducted by Dr. Tim Baker at UW-Madison. And he asked the question, he wanted to know what was the best way to help people quit smoking. And that's a really good question. There's a lot of claims out there. And he did an experiment, a large experiment, in which 608 participants provided data. They came in and they participated in the study. Some of them were given medication to help them deal with cravings for smoking. Some of them were given nicotine replacement therapy, and Dr. Baker and his colleagues did a huge analysis on that. They also had measures of how the person felt during the time, how long they'd been smoking, what their age was. So there's this enormous set of data, and we're going to work with it. And it turns out that we're gonna see some relationships. We're gonna see some really cool stuff, but we're also gonna see some mistakes, some errors, some very clear problems in data, and that's another one of the issues we've got to remember with when we're dealing with real data. Doctors Janet Hyde and Marilyn Essex, and also at UW-Madison, provided us with data from what we call the Maternity Study, and this was the Wisconsin Maternity Leave and Health Project and the Wisconsin Study of Families and Work, and this was 244 families that provided data to Doctors Hyde and Essex. And the data were on questions like, and things like, what's your income level, what was the gender of the child. So this was a study on sort of marital satisfaction and health before and after a couple had their first child in Madison and Milwaukee. So there's a lot of really cool stuff, a lot of cool data. These data sets wind up being, they're really huge. And what you see over here is a capture of a spreadsheet of some of the data, but we'll be working with that and subsets of that in order to illustrate some points. Now, why did we select real data? Well, we selected real data because it turns out that we think that real data are better than sort of the alternative. Well, what's the alternative? The alternative is made up data, fake data. We might want to illustrate some point in the book or in lecture. I might want to illustrate something about how to do something, and it really undermines the value of psychology and psychological research if we can just make up numbers. I think it means a lot more to be working with real data. It also means that we can spend less time talking about where the data come from or what they're from and so on and so forth. I can just say, these are data from the maternity study, and everybody will go, oh yeah, that's right. That's that study with 244 families from Madison, Milwaukee, and so on and so forth. They'll all say, these data are from the smoking study, and you all say, oh yeah, that's Dr. Baker. Yeah, that's right. He looked at what was the best method to quit smoking and so on and so forth. Otherwise, I might have to explain the experiment or the research, and take 5 minutes and then tell you what the numbers are, where they came from, and so on. Hopefully, this will expedite. That will quicken that process. Now, the syllabus has listed a few goals and objectives, and I want to talk through those a little bit. Hopefully, at the end of the semester, you'll have developed an understanding of what data represent. You'll be able to utilize methods for summarizing and describing data. You will have developed skills for performing basic data analyses. You'll be able to draw inferences from samples to larger groups. You'll be able to conduct statistical analyses on a personal computer and develop a critical attitude in the reception of statistical information. These are the goals I have for you, and hopefully through my teaching and through your learning, you'll be able to do these things when we're done. Now, I'm going to do a lot of different things in order to get some of these points across. We're going to have reading assignments. We're going to be doing direct instruction, which is a teaching technique that I like to use for this class. I'm going to be doing some PowerPoint lecture. I'm going to be doing PowerPoint demonstrations. I'm also going to do what I call on-the-board practice, where I actually do an analysis or do a technique on the blackboard or on a sheet of paper if you're taking the online section of this course. We're going to be doing lab exercise. We're going to be doing lab practice. We're going to be doing problem sets, and then you're going to get feedback on all of these, and then you're going to rinse and repeat. Maybe not rinse, but just repeat. So for each unit, we're going to be working through this cycle, through this routine, and hopefully you'll see that we're going to be doing this about once a week. We're going to have a reading assignment. We're going to do direct instruction. We're going to have a lecture. We're going to do some demonstrations. I'm going to do some demonstrations. We're going to practice on the board. We're going to practice in lab. We're going to do exercises in lab. We're going to have a problem set where you're going to get feedback. We're going to do it again the next week, and so on and so forth. This is our textbook, Learning from Data, the third edition of this book, An Introduction to Statistical Reasoning by Art Glenberg and myself. Yes, that's me. I'm an author on this book. From this book, you're going to get the reading assignments, but you'll also see that there'll be explanations of techniques in there. There'll be countless examples. There'll be definitions of key terms. There'll be formula, practice exercises, and tables. And put this little nugget in the back of your head. The tables that I'm talking about are at the end of the chapter, and as we get late in the semester, the second half of the semester, we're going to be doing hypothesis testing with various techniques. And there's a table describing outlining each one of the techniques that we're going to go through in the second half of the semester. So keep that nugget in the back of your head if you want to know how to do something. That's going to be in the back of those chapters. We're also going to be working with this Psych 215 student workbook that's available in the bookstore. This workbook I constructed to go hand in hand with the textbook. It has in it the on-the-board exercises we're going to be working through. It's got a checklist of objectives or of skills that you should be able to do at the end of each chapter or unit. And it's step-by-step Excel instructions. It has a bunch of examples as well. There are practice exercises. It also has pages of formulae condensed in a nice packet, and a decision tree. Again, this is going to be working hand in hand with the textbook. Now, this book you should have with you when you're working on a computer, when you're working with the lab. This is an instructional book for how to do things on a computer. In our lab sections and on the computer, what we're going to be using is we're going to be using a program called Excel. It's a spreadsheet program. It was originally developed for accountants to do things. But with the help of add-ins and the graphical utilities, with the help of formulae and functions and a little logic, what you're going to be able to see, what we're going to see, is that this can do amazing things. In fact, in my own research, I hardly ever get out of Excel. You're going to hear from other students, oh, I got to learn SPSS, or I got to learn SAS, or I got to learn Minitab. There are all these statistical packages, computer packages out there, software packages. And a lot of people teach different ones. The problem with all of those is they change, and often they're difficult to understand, like what's exactly going on. Some of it you just plug stuff in, and then you get an answer, and you're like, where did that come from? And you don't really have any idea. Excel is going to force us a little bit to know more about what we're doing and why we're doing it. But we can do all the analyses that we're going to learn in Excel. Excel is widely available. Hopefully you have a copy of it if you want to work on this at home. If you're in the online section, this is really a program that I require. You're going to need Excel in order to do these programs. Now, on the lab computers and on the computers on campus, Excel will be loaded. It's part of the Microsoft Office package. Now there's a new upgraded Office package, I think that 2014 that's coming online, and we might have a few glitches, we might have a few bugs, we might have a few things that we got to deal with, but we'll talk through those, we'll work through those, and so on and so forth. But Excel is a super powerful program. I love Excel. I often tell my students that if I wasn't married, I'd marry Excel. I mean, if she had a good body, too, and a nice personality, I probably would marry her. I mean, because she's awesome. But, but she is a computer program, after all. Okay, I'm going to move on now. Okay, your grade. This is something you're probably really interested in. There's 11 problem sets throughout the semester. As you'll notice, there are 11 units in the workbook. Each one of those problem sets, at the end of a workbook unit, you're going to be assigned a problem set. It's worth 3 points each. The best 10 count. That means that if you don't do one, or one you just totally blew up and you got a horrible grade, I drop it. Your best 10 count. So that's 30% of your grade. 10 times 3 is 30. There are 2 exams. They're worth 35 points each. The 2 exams each have 2 parts. One's given around the midterm time, one's given around the final time. They're not cumulative in the sense that what I teach in the second semester, second week, I'm going to ask on the final exam. But statistics is a cumulative process. You're going to learn a lot of things that you're going to use throughout the semester, like computing sum of squares or standard deviation or something like that. The 2 exams have 2 parts. There's the lab part worth 15 points, which entails computations on small sets of data. And then there's an in-class portion, which is short answer and matching and true-false and interpretation and so on. There's no computations on that. That's worth 20 points. So each exam is worth 35 points. 2 of them with 2 parts. That's 70% of your grade. I also give out extra credit. If you really nail something, you give me a great answer, I'll give you a star. A star is worth half a point. You may get a star even on your homework or your problem sets if you do really well. That's a maximum of 5 points on your grade. The problem sets, though, I have a special policy on, and that is that I know from psychological research that if you don't practice something correctly, you won't do it right later on. You have to practice it correctly. So in the syllabi, I say that my swim coach used to say, practice doesn't make perfect. Perfect practice makes perfect. If at first you don't succeed, you're going to get a resubmit. What that means is I'll write on your homework or indicate somewhere that you need to correct your mistakes and resubmit this. And you only get a grade when your homework or your problem sets are done correctly and completely. So you can get the maximum 3 for doing it correctly and completely on the first time. I knock off a point for each successive try. So hopefully there's some incentive there to do it right the first time. The word resubmit is a key word here. What that means is that you gotta try again. And I will accept homework. I will accept problem sets for limited points up until the last day of class. I really only have one rule in my class. I know that there are a lot of professors on their syllabi talk about things like texting and Facebook and computers and iPods and iPads and phones and so on. They might even have a policy on eating and drinking and snoring and sleeping and all sorts of stuff like that. Basically, the only rule in my class is don't be an a-hole. All right. If you're going to have your phone on you, silence it. Otherwise, it's going to interrupt everybody. If you're Facebooking in class on your computer, if you use your computer to take notes and you flip over to Facebook, I could care less. You're the one paying me. I'm not paying you. Well, or maybe your parents are, or maybe you've taken out a loan. That's on you if you want to be distracted in class. And we know from a lot of experiments that it's hard to maintain focus when you're doing multiple things at once. So this class is not easy. And if you're spending a lot of time on Facebook and tracking down your friends or whatever other social media stuff or watching YouTube videos or something like that, it's not going to work. But I could care less. As long as you're not disrupting anybody else in the class, I don't care. If somebody's disruptive, if you can't keep your eyes off somebody else's screen, if you're like, oh, it's disruptive, he's watching something I don't want to see, that, probably the best bet to do is to move then. Get out of that field of view. But my only rule in class is don't be an a-hole. And if you're having trouble, please talk to me. Email me. We can set up appointments during office hours or outside of class or outside of even office hours if you can't do that. I want to help you get through this. We have a supplemental instruction, a tutor, Callie Horton, who took this class with me, and she's more than willing to help you too. There's other resources as well. What I don't want to be is inaccessible. I will always make time to meet if you want to talk to me. So that's it for an introduction to the class. Again, if you want to hear a little bit more about me, I posted some introductions on the D2L site that were somewhat long-winded, but we'll go from there. And if you have any questions, please email me. Otherwise, I look forward to a great semester, and we'll see you guys all soon. Bye-bye.